But I will discuss just practical scanning using an example project that we did last year. And so this is really hands-on work that we do. So I'd like to first ask you a question. How many of you have been involved in practical data collection in forests? And I'm discussing about geometrical data here. So do you have any experience in the audience? Yes, some hands are coming up. Okay, good. So I will show you a video as well. So we'll just go through basics of what's happening. This is the laser scanning, or some people call LiDAR data. I could have shown you some stuff from our actual time in the forest, but unfortunately, I made this presentation while arriving here. So that data is at home, so I'll show you just some video from the internet. I think I can use this, yeah. Good. So, very short content, who we are, and then we'll go straight to the data acquisition from the forest. And there's been already some kind of discussion about what kind of detail should we have and everything, and let's go to that in the end, because it's always a question of what you want to use the data for, and better quality data always costs more than lower quality, more detail costs more. So we will come to that in the end. So we are a small company based in Helsinki, working mainly in Finland and in Estonia. We are reseller of scanning systems from the terrain, from the ground, from the car, which we've been doing a lot lately. So we're measuring roads with our customers. But also, you can put a scanner on a drone, on a helicopter, on a big airplane. And of course, the parties that really map in a large scale, they always use an airplane, or sometimes even satellite, of course, because you can achieve more in less time. Then it's a question of accuracy of the data, where you can use it for. Well, a customer approached us asking to use a drone LiDAR system scanning forests, and he had like 3 to 4 different types of forests in mind. I mean, we're talking about a few hectares here. And so there was young forests, some 40-year-old forest, and then an old forest, and preferably also mixed. So not just one species, but more. What was atypical in this request was they wanted very high accuracy data. I mean, not just relative accuracy, which you can't distinguish on images, but absolute positional accuracy, because that's also very difficult to achieve in forest environment. Everyone who's been working there knows that. And we kind of wondered and exchanged a lot of discussion, like, what do you need it for, and how we can achieve it. But anyway, that was their idea, and I will tell you later why. And they also wanted to test these forest plots from above the forest, so from a drone, and also from the ground using terrestrial laser system. And yeah, you can see those types of forests that we are discussing here. So very different. In particular, the young forest in question, they wanted to be kind of like unmanaged, so in a pretty wild state. So you have a lot of undergrowth also between the trees, and also for humans, it's difficult to move in that kind of an environment. And the equipment that we use can be seen here, and I will show you the video next just to see how it works. And then we also did a groundwork, and we did the data acquisition in both cases in one day. So the rest is processing. So luckily I have some technical help here to start the video. Right, so in this video you will first see the system itself, how it's kind of, what parts make it and what is needed. So we have a laser scanner in the middle, this one, and all the components are important in the sense that if you kind of go for wrong options. You might have very quality components for laser scanning, for instance, but the end result is not what you expect. Whoa, that was sharp. The Rycopter, the drone here, that's pretty large. It's actually it's 2 meters in diameter, so it's really, really big. When we brought it to Finland, there were drone people coming to the show and they were saying like, oh, that's the largest drone that we have in Finland. And I say, possibly, I have no idea because I'm not a real drone expert. In relation, there's a scanner, but even though it's called laser scanning, when you do it in a mobile way like this, it's never just the scanner itself. You have a GPS devices on board, you can see the antennas, and in particular you have something called IMUs, that's the inertial navigation data. So all of these data are actually put together in the end processing. Here we have the flight going on, so the data is gathered during the flight. This is pretty heavy because we don't have the miniaturized equipment yet for this level of data. There are, let's say, lighter scanners, and you can always build everything lighter, but the quality is not the same, so we have to use slightly heavier equipment. And soon you will see some of the data. It's not real-time. You can do also real-time data acquisition, but once again, for those parameters that our customer wanted, you can't really have that accuracy, so it's always post-processing. There's a flight plan and trajectory in the air, and there is the operator, and there's a pilot in the background, 2 people. You can, of course, put the operation itself, the data acquisition, on full automatic. So if you have one pilot to fly the system, he can just start and stop it when needed. So that's also possible. Okay, so this is the landscape. There's some forests and fields, and I'm just waiting that we get to see some of the data here. These are the kind of systems that we would like to have, as discussed earlier, in beyond visual line of sight drone acquisition, and of course with the battery power or some kind of power to, actually I don't think at the moment you can use batteries, that you would have longer flight times, because the data acquisition could go on for hundreds of kilometers, like it is the requirement in this type of power line jobs. Okay, I think we are finished with this one. So next I will show you some images of our data and results, basically, and lessons learned. So there should always be some kind of lessons on when you do something like this. Okay, so we got the accuracy and the detail that the customer wanted. We had like more than 15,000 points per square meter. And if some people think that, oh, that's too much, we don't need that much, fine, you can always filter some of it away. But we can also see that in the densest parts, that's always the problem of LiDAR. I mean, if you have a tree trunk, something that you can't see through, a human can't see through, of course, no photonic system can see through it either. So we got the requirements, and he got the parameters that he wanted. And I've put here that this kind of data could be used as an HD map for autonomous vehicles. So the HD map concept is something coming from the car industry, or those who develop autonomous vehicles. There is no standard. It just means that you need to have a more high accurate map compared to the regular maps that we are using, like Google Maps or so. But the one requirement is rather big. That's the positional accuracy, because the current paradigm is that you need the map to be good so that your system can autonomously go through it. Until they develop systems which don't need this, this is where we have to live. And as for the forests, I'm sure that you're more interested in the forest part here. The young forest that was really thick with the under vegetation, it was very difficult for a human to go there and actually scan. Yeah, you could do that. But the next question is, how do I get my scan positions together? So really, I think UAV or something acquired from the air is much better solution for those. The 45 years old forest, that was like either or. Also in question of time, because we only had a few hectares to scan. And in the old forest, there we start lose the details of the trunks, for instance, in the bottom near the ground. So in the end, of course, the method that you use depends on the parameters that you have, and secondly on what is the size of the area that you're interested in. Because if we have square kilometers, very large area, then the current drone system, which is developing, it's more inefficient than, let's say, helicopters or airplanes. But if we go to smaller areas, then once again, we might have use for drones over there. And then, of course, terrestrial LiDAR, yeah, we can do it pretty quickly, but on the other hand, it still takes more time if the area gets larger. And I've also noted that the big spruces that we had in this old area, I mean, it was ripe for cutting. So they're really, really thick, so it's difficult. We know that already from the past. It's the same issue that we have in the national data, of course, that you get very few points underneath these spruces that you might even have a hole. We had data, but I mean, still much less than the 1,500 square meter points per square meter. And here's the forest, or the 45-year-old forest, sorry, from above. I mean, it's a mess of points, basically. It's colored with the RGB images. Little bit seen from the ground. There was a road going past it. So this is the UAV drone data is on your left, and the terrestrial LiDAR data is on your right. So you can see a difference. I mean, there are differences in density and things like that. And of course, I have to say here that we use a LiDAR that has multiple returns, so it penetrates more. If you use a LiDAR which doesn't, so then you don't get this kind of data. And a profile from the forest. This is the terrestrial scan. And sorry for the detail, but you can see we have tree trunks and everything better. We also have the tops of the trees. So you can get the height of the trees from the ground as well. It works in pretty dense forest as well, so it's quite good. And another profile, this is from above, from the UAV. I think I forgot to mention that it's 50 meters height. And you can see that some of the bottoms of the trunks, there are pieces missing, so we get less data over there. But yes, we get excellent data from the growth themselves and the greens and the leaves and everything. And combined, the white one is the terrestrial and the green one is the UAV data. So then we get, if someone needs really the whole tree. And of course, some will say that, okay, we don't need this detail, but believe me, there are forest scientists. The first ones I met was in 2007 in Silvilazer, and they are interested in so minuscule details that you can't really answer their request. But sometimes, I mean, there is something here for everyone, basically. And if you can do with less data, that's fine as well. But we can produce pretty dense data now as well. And yes, the organizers asked me to present some challenges, of course, and they always are. And of course, it's always the software. It's always the software, isn't it? The hardware is really getting good. And hardware development also takes a lot of years, because if you start from the basics, well, you have a long way to go. But the software, we have like in forest studies, we have software for many things, but when the data itself changes, you need to either to kind of build that software again or build a completely new software. Sometimes they just can't handle the data that comes out of these systems. And education, and I'm in particular talking about the acquisition of data. I mean, people who do this in the field, because there's very little of it taught in schools. The systems and changes that you have to go through them really carefully, as we do with our clients, because then you can be productive and get the results that you want. All right, I think this was it. Thank you. Any questions?
Kari Nieminen, what kind of equipment are you using to get the RGB images?
Just a normal camera, basically. In this one, we had the Sony 7, Alpha 7.
So you are using this same drone?
Yeah, it's in the same drone, simultaneously with the LiDAR. And you can also put hyperspectral cameras or whatever additional is there. Once you get timestamp connecting all of this data together, then you can combine it in the computer. Other questions?
So, are you selling these equipments, or are you selling this as a service? And other question that who is your typical customer at the moment? Is it like Stora Enso or this kind of big forest companies, or who is buying this kind of services?
Our clients are selling normally this service. We were involved in here because of the requirements were pretty high, and we have the knowledge at least to try for them. And our typical customers are the consulting companies who you can order then to do some kind of measurement work for you. They work either on the building sector, on the infrastructure, some work also on forest sector. So that's the typical one.
I got the last line. So what kind of education are you looking after? So is it based on something already given education, so kind of adult education, or do you expect something in the universities, or in which level?
That's a tough question, I have to say, because I've been thinking about it myself quite a lot. Our people come mostly from land surveying sector, also our consulting customers. But there is a shift to newer measurements, but it's quite a difference compared to the traditional methods they're using. And I think the teachers are not getting the training that they need to have, then they could teach the youngsters who come to them. It could also be adult training, and actually there are some cases of it. Like myself as well, by the way. I did some two-year evening study. And that's because when you have the basics in something, then you put this on top, and then you can combine it, and that gives you the excellent results. Because if you don't have anything, then it's of course a longer training. But I mean, what sector it could be? We have been discussing here that, for instance, the virtual forests are now done by gaming people, which is absolutely fine. They have the skills for it, and I've studied with the game players myself, how to create the models and such. But they have other things in mind usually than we have in mind when we measure. We still need the accuracy. I mean, that can be 1 millimeter, 1 centimeter, 10 centimeters, or 1 meter accuracy. But we need to understand this when we do something and then we model it. And the gaming people, they want something that runs smoothly on a computer and looks good. So, of course, when you have teams working together, you can combine it, but you have to press really hard if you want to have your requirement over there. Because then if you have like autonomous vehicles moving around in models which don't have the specified accuracy, then it's going to be kind of a disaster as well. So, so it's difficult. I mean, the skills comes from many fields. So, of course, I mean, maybe there is nothing existing at the moment, really.